morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about different factors that are being used in illumination systems. What are the different factors that are to be considered in the illumination system and how to choose the right lighting fixtures in this illumination system? The first one, what are the different factors to be considered? The first factor is utilization factor. The first one is utilization factor, or you can call it as coefficient of utilization. Utilization factor or coefficient of utilization, it is defined as the ratio of, total lumens reaching the working plane to the total lumens given out by the lamp. That means here, if you can see a lamp, it will be giving some kind of lighting. So, it will be giving some kind of lighting which is measured in lumens, and the amount of lighting which is being reached on the object is different. So, this utilization factor is the ratio of total lumens reaching the working space, that is this one, reaching the working place, to the total lumens given out by the lamp, to the total given out by the lamp. So, ratio of this one to this one is nothing but the utilization factor. So, the ratio of these two will give you the utilization factor. Next one, maintenance factor. Maintenance means due to some kind of accumulation of dust. Means, if you can take an example of a tube light which is placed on a wall. So, some kind of dust will be there on the tube light. So, when the dust is being accumulated on the bulb, on normal bulb, or on the lamp, or on CFL or incandescent lamp, or any kind of bulbs or lamps, because of this dust, the maintenance factor, you can see that due to the accumulation of dust, dirt or smoke, mostly in the kitchen areas, the lamps, they emit less light when compared to the other lamps. Okay, when compared to the new ones, when the dust or the smoke accumulates on the bulb, it illuminates very less amount of brightness. And similarly, the walls and ceilings also, after being covered with the dust or dirt or smoke, do not reflect the same amount of light which is being reflected when they are new. Means, you have different types of lightning, that is direct lightning and indirect lightning. Direct lightning means direct from the bulb, the light falls on the object. Indirect lightning means the lightning falls on the wall. This is your wall. It falls on the wall first and then it reflects back. Okay. So, this is direct lightning. This is indirect lightning. In direct lightning, if any dust is present on the bulb, dust or smoke is present, the luminous, like the brightness, reduces. And in this indirect lighting, if any dust is present on the walls, if any dust is present on the walls, then also this reflected light, then also the lumens of this particular reflected light reduces. So the walls should be clean, as well as the bulbs also should be clean and dust free in order to provide good utilization factor. So same output of light which is reflected when they are new. So lumens, it is the ratio of illumination under normal working conditions to the illumination when the things are perfectly clean. Maintenance factor is nothing but the ratio of illumination under normal working condition and when everything is clean. Means this one is with dust or smoke, and this one is when they are dust free or when they are new. Okay, so when they are new or when they are dust free to the ratio of when they are with dust or smoke. So this gives us the maintenance factor. The ratio of these two will give us the maintenance factor. Next one is depreciation factor. Depreciation factor. This is mainly the reverse of maintenance factor. Depreciation factor is the reverse of maintenance factor and is defined as the ratio of initial meter candles to the utilization to the ultimate maintenance meter candles on the works space. So it is the reverse of maintenance factor, that is the ratio of initially when they are new, so that to the ratio of meter candles under working condition. So when they are new to the working condition gives us depreciation factor. And maintenance factor means when they are working condition by new condition is maintenance factor. Okay. So next one, waste light factor. Next one is waste light factor. Whenever a surface is illuminated by a number of sources of light, number of sources of light means in a particular room, if there are number of lights, there is always a certain amount of waste of light. There is a certain amount of waste of light on account of overlapping and falling of the light outside of the edges. So if there are number of bulbs which are being placed nearby in a room, so the light reflects. So the light reflects here. So this light as well as this light are being overlapped here. So this is nothing but a waste light. This is nothing but a waste light. Okay. So whenever a surface is illuminated by a number of whenever a surface is illuminated by a number of sources of light, there is always certain amount of waste of light which is being overlapped from one bulb to the other bulb. On account of this overlapping and falling of light outside of the edges, of the surface, the effect is taken into account, and by multiplying the theoretical value of lumens required by 1.2 for a rectangular area and 1.5 for irregular areas and objects such as heads and moment, etc. are being considered. That means the bulb spacing, the spacing between the bulb is required. The minimum amount of spacing should be there between the bulb in order to reduce the waste light factors. The next one is absorption factor. In this, the atmosphere is full of smoke. Such as in boundaries there are possibility of absorption of light. The ratio of total lumens available after absorption to the total lumens emitted by the source of light is called absorption factor. Means when there is a lot of smoke or fumes which are placed in that particular area, the lumens which are given out from the bulb is different from the light which is falling on the object. So this and these two are different in absorption. So this is the ratio between the total lumens available after absorption to the total lumens emitted by the source of light is called absorption factor. Its value varies from unity to for clean atmosphere to 0.5 for other areas with disturbance, with smoke. Next one is beam factor. The beam factor, the ratio of lumens in the beam of a projector to the lumens given out by lamps is called as a beam factor. This factor takes into the account of absorption of light by reflector and front glass of projector lamp. Its value varies from 0.3 to 0.6. So, the absorption factor, the first one, waste factor. Waste factor varies from 1.2 to 1.5. Next one, absorption factor varies from 1 to 0.5. And beam factor varies from 0.3 to 0.6. So these are the different factors. Here you can see the reflection factor. When a ray of light falls on the surface, it is reflected from the surface at an angle of incidence as shown in the figure here. The thing is, in indirect lighting, the bulb is placed in this manner. So the light first falls on the roof and after that it reflects back. So the reflection factor is nothing but a measure of the amount of light which is being reflected from the roof. So you can say when the ray of light reflects on the surface, it is reflected from the surface at an angle of incidence. This angle of incidence. A certain portion of incident light is absorbed by the surface. That means some amount of energy, some amount of light is being absorbed here, and the remaining light is being reflected here with an angle of incidence. So, the ratio of reflected light to the incident light is called as reflection factor. So, reflection factor means ratio of reflected light to the ratio of incident light. Means ratio of this particular, this is your incident light, this is your reflected light. Ratio of these two will give you the reflection factor. And reflection factor is always less than unity. It is always less than unity because reflection factor is always less than the incident factor. This particular light is always more than the reflected light because some kind of light is being absorbed on the roof. So, always the reflected light is less than the incident light. So, the reflection factor is always less than 1. Next one is plane angle. A plane angle is the angle subtended at a point in a plane by two converging lines. It is denoted by a letter theta and is usually measured in degrees or radians. So, theta is equal to arc by radians. 1 radian is defined as the angle substituted by an arc of a circle, where arc of a circle whose length is equal to the radius of the circle. Next one is solid angle. Solid angle is the angle subtended at a point in space by an area, that is angle enclosed in the volume formed by numerous lines lying on the surface and meeting at a point. It is usually denoted by omega and it is measured in steradian. How to choose the right lighting fixtures? When selecting a lighting fixtures for commercial spaces, several factors to be considered. Like, first one is function. Determine the purpose of each area or room. And select lighting fixtures accordingly. Fix lighting fixtures accordingly. For example, if you need a bright task lighting for workstations, desk lamps and under cabinet lights may be suitable. If you want to accentuate architectural features, spotlights are being used. That is based on the place, whether it is a reading place, working place or for decoration. So, based on the application, we need to decide the different types of bulbs or lights and the spacing between the bulbs and number of lights should be used on a in a area, in a room or in an area. Next one is style. Consider the overall design aesthetic of your space and choose fixtures that complement it. Whether your style is modern, classic or industrial. That is, whether you are using for industrial purpose or for decoration purpose. There are lighting options available to suit your preferences. Next one is size and scale. Ensure the size of the fixture to decide the fixture is nothing but the holder. To place a bulb. So based on the brightness, we will decide the size, and based on the room size also we will decide. Next one is light output. Access the desired light levels for each area and choose fixtures with appropriate brightness. Different rooms may require different levels of illumination based on their function. Next one is energy efficiency. In today's environment, it is important to consider energy efficient lighting options. Means more brightness at a low consumption. So mostly LED bulbs are being recommended instead of CFL bulbs. Next one, maintenance and lifespan. Evaluate the maintenance requirements and lifespan of a lighting fixtures before making a decision. Like, opt for fixtures that are durable, easy to clean and have long lifespan to reduce the replacement and minimization disruptions in commercial settings. So in order to reduce the replacement cost, we need to place a bulb or a light. We need to fix the holders in order to easy to clean and have long lifespans. In next session, we would like to discuss about various illumination schemes. Thank you.